Intermediate Algebra for Statistics, Sections 1.2, 1.3, Part 2. Lesson Objectives. Use a linear model to describe an authentic situation and use the model to make predictions. Determine the intercepts of a linear model. Lesson Objective number 3. In this section we'll use a scattergram, or sometimes called a scatter plot, to help us sketch a line that can be used to describe an authentic situation, such as the descent of a hot air balloon. We will use the line to make estimates and predictions about the situation. Let's do an example. Example 4. A person lowers her hot air balloon by gradually releasing the air from the balloon. Let A be the balloon's altitude measured in feet above the ground after she has released the air in the balloon for T minutes. The variables of T and A are listed in the table. So T is our independent variable measured in minutes, and A is our dependent variable measured in feet. Number 1, create a scattergram of the data. Number 2, draw a line that contains the points of the histogram. So here's the scattergram. If we look on the x-axis, this is T measured in minutes. Our y-axis is A measured in feet. And we can see here that as time increases, the altitude decreases. For number 2, in math, we say a line means a straight line. We can draw a straight line through the points in the scattergram. Definition. If two quantities of an authentic situation are described accurately by a non-vertical line, then the quantities and the variables representing those quantities are linearly related. So when we talk about two variables being linearly related, if we were to graph the relationship, it could be modeled by a straight line. A model is a mathematical description of an authentic situation. We say that that description models the situation. A linear model is a non-vertical line that describes the relationship between the two quantities in an authentic situation. Example number 5. Use the linear model shown to estimate the balloon's altitude when the air has been released for 5 minutes. Number 2. Use the linear model to predict when the balloon's altitude is 400 feet. So this blue line is going to serve as a model, and from this model we can estimate altitude, and in this question we can estimate the time. So here we have our model. We are given that the time T is equal to 5, and we are going to estimate the altitude, and we see that the altitude is about 1,200 feet. So this point here has coordinates 5 and 1,200. So if we locate the point on the model, the T coordinate is 5, the A coordinate is 1,200. So if we were to interpret this, we would say, according to the model, the altitude is 1,200 feet when the air has been released for 5 minutes. Number 2, we're going to use this model to predict when the altitude is 400 feet. So this time we're given an A and we want to find T. So we go back to the model. We go to 400 altitude, and we want to see what X this is, and we would estimate that T would be equal to 9 minutes. So the T coordinate is 9, the A coordinate is 400. So if we were to interpret this, we would say, according to the linear model, the altitude is 400 feet when the air has been released for 9 minutes. Definition. An input is a permitted value of the independent variable that leads to at least one output, which is a permitted value of the dependent variable. So another way of saying input, these are values that we can use for the independent that would make sense in the problem. The output is the values of the dependent variable that would make sense in terms of the problem. Example 6. Consider the scattergrams for the data situations 1, 2, and 3 shown. For each situation, determine whether a linear model would describe the situation well. So we go to the first one. Clearly, linear model would fit this situation well. The second one, a linear model would not, because this is what we call a parabola. So a quadratic model would fit this data better. And we'll talk more about that later on in this class. And the third situation, these points here do not make a line. In statistics, we sometimes call this a cloud of data. There is no linear relationship or any kind of relationship between x and y in this case. Lesson objective number 4. Definition. A intercept of a line is any point where the line and the axis of a coordinate system intersect. There are two types of intercepts of a line sketched on a coordinate system, with a x-axis and a y-axis. Here we have our straight line. This is the y-intercept 3, because that is where the line is intersecting the y-axis. We can see that the x-intercept for this case is 6, because this line is intersecting the x-axis at 6. The x-intercept of a line is a point where the line and the x-axis intersect. The y-coordinate of an x-intercept is always 0. The y-intercept of a line is a point where the line and the y-axis intersect. The x-coordinate of a y-intercept is always 0. So again, if we look here, the x-coordinate of the y-intercept is always 0. And if we look at the x-intercept, the y-coordinate is always 0. Example 7. An underground rock band manufactures 500 CDs of its original music and tries to sell the CDs at the band's concerts. Let P be the profit, measured in dollars, from selling a total of N CDs. Some values of N and P are listed in the table. So profits are dependent because it depends upon the number of CDs sold. N is our independent variable. So number 1, we want to sketch a scattergram of the data and then draw a reasonable model. Number 2, using the model, we'll estimate the band's profit from selling all 500 CDs. Number 3, if the band loses $975, estimate how many CDs will have been sold. Number 4, estimate the p-intercept of the model. What does it mean in this situation? And number 5, estimate the n-intercept of the model, and what does it mean in this situation? Let's do the scattergram first. So if we plotted on graph paper our 5 data points listed here, and then we draw a line to connect them, we have our linear model. The blue arrow shows that when n is 500, that leads to a profit of about $2,000. So if the band sells all 500 CDs, the profit will be $2,000. Number 3. Now negative values of P represent a loss. So if we have a loss of negative $975, we can estimate that the number of CDs sold is about 75. So if the band sells 75 CDs, it will lose a $975. Number 4, we are asked to find the p-intercept. So P is this axis. It's right here. So what this means is when our independent variable is 0, this is our profit. So if n is 0, the number of CDs sold is 0, the profit will be a negative $1,500. Number 5, to find the n-intercept, that's the point that crosses the n-axis. So we see that it's 214, and then our profit is 0. Sometimes this is known as the break-even point. So what this means in this situation is if the band sells 214 CDs, the profit will be 0. For the profit to be positive, they will have to sell more than 214 CDs. Here's the reading assignment from the text and the suggested problems. Thanks for watching.